watt governor. Here you will find a central load on the sleeve. Generally, watt governor is not used for high speeds. So Porter governor has been developed. This Porter governor can be used for high speeds. The modification is that it has a central load on the top of the sleeve. Now we'll derive the height of the governor, speed of the governor for this explanation. We can find the expression for the height of the governor by instantaneous center method. This is a method. The instantaneous center I lies, capital I, lies at the center of intersection of the extension of the line AC and perpendicular to spindle axis through P. এতিয়া আমি কি কৰিম derivation কৰিবৰ কাৰণে এটা মেথড ইউজ কৰিম যে মেথডটো ইনষ্টেন্টেনিয়াছ মেথড বুলি কয় তো ফাৰ্ষ্ট অফ অল instantaneous center to me কেনেকৈ উলিয়াম the instantaneous center will be at the cross section of the extension of AC line a figure to দেখাই পোৱা যায় AC line আৰু line perpendicular to spindle axis through point B. This will cut at point I. AD is perpendicular to IB. It is assumed that mass of the links, arms, etc. it is neglected in the analysis. For simplicity of the mathematical expression, half portion of the configuration is considered. Mane mathematical derivation karone ami half portion of the governor loichu gote portion to loa nai. Now the various parameters are mass small m, mass of each flywheel capital M, mass of central load, smaller radius of rotation in meters, h height of the governor in meters, n speed of the balls in rpm, omega twice pi n by 60, it is in radian per second. Now centrifugal force is given by Fc, centrifugal force acting on the flywheels in newtons, alpha angle of inclination of the upper arm to the vertical. It is important hoy alpha to whole angle of inclination of upper arm to the vertical. Yate upper arm to kuntu hol AC. AC is the upper arm. Vertical boli gole it's a spindle axis dale yate vertical consider korise. So that upper arm is making an angle alpha with the vertical axis. Beta is the angle of inclination of the lower arm to the vertical. So here the lower arm is AB. So AB is making beta angle to the vertical বুলি ক'লে আমি এক্সিস ডালে ধৰিলো vertical লৰ লগত বিটা angle কৰি আছে. Now you have to take moments about point I. At a point I it has instantaneous center. You have to take moment about this point I. So if you take the moment, the various forces here are centrifugal force Fc, load mg, load of mg, that is the load of the flywheel that is acting through AD line. Another force is mg by 2. Mg is the load of the sleeve. As we are considering half section, it will be mg by 2. So here the forces are Fc, which is centrifugal force radially outwards, small mg, weight of the load of the or weight of the flywheels, then weight of the sleeve is mg by 2. Mg by 2 because we are considering half section. If you take moment about point I, you will get Fc into AD equal to mg id into id plus mg by 2 into IB. So this expression you will get. So you have to know how to find the moment about the point. Moment is force into perpendicular distance. This we have already learned how to find moment in third semester, second semester in engineering mechanics. So this should be easy. So Fc rearrange korile will get mg into id by AD plus mg by 2 into IB by AD. Now IB, this IB line can be represented in terms of ID plus DB. So expression becomes mg into id by ad plus mg by 2 id by ad plus dv by ad মানে ib to represent কৰিছো id plus dv. So simplify কৰি আমি এটো expression পালো. Now id by ad, you can from the figure, you now see the figure, id by ad you can write as tan alpha, dv by ad you can write as tan beta. Take few moments and check whether it is right or wrong. id by ad tan alpha, dv by ad tan beta. Put these things, put these values in the expression, you will get mg into tan alpha plus mg by 2 tan alpha plus tan beta. So this is your expression. Now take out the tan alpha from the expression. It will be mg plus mg by 2 1 plus tan beta by tan alpha and the whole multiplied by tan alpha. So it will be tan alpha to into the expression become this. Now tan beta by tan alpha we'll write as q, because for simplicity sake we'll write as tan beta by tan alpha as q. So if I write, it will be tan alpha into bracket starts mg plus small mg plus capital mg divided by 2 1 plus q. This should be the expression, bracket close. Now fc, take the tan alpha to the left hand side, fc by tan alpha, it will be mg plus mg by 2 1 plus q. Now you can put the value of fc. Fc value is m omega square r, and tan alpha is, you can also write as r divided by h. What is r? R is the distance of center of the flywheel fly ball to the spindle axis, radial, you can say radial distance. And what is h? H is the height of the governor. So these things are given in the expression, you can easily put here. So tan alpha value to r by h put korilu, fc value to put korilu. So your expression becomes m omega square r divided by r into h equal to mg small mg plus capital mg divided by 2 1 plus q. So here from omega square to ulialu, omega square to ulialu, finally we'll get the expression as small m plus capital M by 2 1 plus q divided by small m into g by h. This is your omega square value. Now omega square can be represented as omega value can be represented as twice pi n by 60, twice pi n by 60 আমি replace korilu, then you will find the value of n square. So n square value will be m plus capital M by 2 1 plus q divided by small m into 895h. These are all given in the expression. You see this thing, and this should be easy. So finally you will be able to find the height of the governor, that will be m small m plus capital M by 2 into 1 plus q divided by small m into 895 divided by n square. This is given in expression. This is the height of the governor, height of a porter governor. And sometimes what happens, both upper arm and lower arms are equal. So point C and B will lie at the same point, same vertical line. So tan alpha and tan beta will be equal. So Q will be equal. So your expression becomes very easy. So n square will be small m plus capital M divided by small m 8 into 895 divided by h. So this is the expression. Now sometimes you will consider the friction also, because when the sleeve moves up and down on the spindle, there may be some friction between them. So considering the friction, the expression will be n square equal to mg small mg plus capital mg plus minus f divided by 2 1 plus q divided by small mg 895 by h. You can see in the expression. Similarly, if we consider q equal to 1, what will be the expression? You put q value equal to 1, then the expression will be very simplified one. F is the frictional force here in newtons. Positive sign is when speed increases. That means when the sleeve moves up, you will consider that to be positive. Negative sign is used when the speed decreases. Speed decrease all that when the spindle speed decreases, its sleeve moves down, and you can consider it as negative. Comparison of the comparison of this equation, above equation, if you compare this above equation with one governor, I will see that the height of the governor is increased by 1 plus capital M by small m times taking q equal to 1. This thing is important. So thank you.